So, I will discuss about the more quantization, why we require more quantization, that is what I explained in last class. So, we have seen that sodium D1 lines, sodium D lines, it is basically composed of two lines, D1 plus D2 lines, right, and then that was not explained using Bohr-Sommerfeld theory, and then hydrogen H alpha line, it is composed of 5 lines, that also not explained, and then also Zeeman effect. Okay. So, any spectral lines is split under magnetic field, split into 3 lines. So, why it is happening? So, that also not explained in case of normal Zeeman effect. Anomalous Zeeman effect will come later. Okay. So far we have considered that electrons in orbit. So, it is the basically planar motion. So, this plane can take in any direction in space. Okay. So, there is no restriction of the orientation of the plane of orbits in space. It can orient in any direction. So now this Sommerfeld again put this condition that no, it cannot orient in any direction. Here it is again quantized. So, that is called space quantization. Space quantization. So, electrons are rotating in a orbit, elliptical orbit. Okay. Electrons rotating in a orbit. So, it has angular momentum. So, direction of angular momentum is basically perpendicular to the plane, plane of this orbit. Okay. So, this is pk, say pk, right. So, earlier I was writing p theta and corresponding this quantum condition was basically p theta d theta equal to n theta h, right. So, n theta, that I mentioned that n theta we have taken as a k. So, now this index also I am using k pk. So, that is the direction. Now, this if these planes rotate in another direction, say this way, okay, another orientation. So, this direction is this. Okay. It is pk. Now, this direction is this. Okay. So, similarly another direction. So, this pk direction, it can be any direction in the space. Now, quantum condition is applied again. No, in space it cannot orient in any direction. This also it will be quantized, like this, and another quantization was that PR dr equal to nr h. So, third quantization, space quantization, it was considered that p phi, what is phi? Phi is basically the, if you consider, forget this one, if you consider a reference direction in space, if it is this, so then the direction of the angular momentum pk this is this direction. So, what about the angle between this reference direction and this angular momentum direction? So, this angle is phi. This angle is basically phi. Okay, this angle is phi. So, another third coordinate we are using, r theta phi in 3 dimension, basically r theta phi, that is the. So, another number parameter or coordinate, that is phi. So, this phi coordinate also will be quantized. So, angular momentum for this phi corresponding. So, d phi, right. So, it will be say n phi h. So, this is another quantization. Okay. So, here just simple way we can tell that, find out that this this pk or this orientation of the orbit, plane of the orbit is such that its direction, angular momentum direction, if you take the projection along this fixed direction, this projection will be pk cos phi, okay. So, that will be quantized. So, that will be quantized if I just write, forget this one, just using the similarity I have written. So, pk cos phi will be m h cos, okay, m h cos. So, m can take different value, but it's the integer value. So, pk cos phi will be m phi. So, this is a quantum number, m is quantum number, and this quantum number is called magnetic quantum number. Is the magnetic quantum number. Okay. So, this find pk cos phi equal to m phi, and we know that pk equal to k h cross, right, pk equal to k h cross. So, from here what we are getting? If I take ratio of these two, so I will get cos phi equal to m by k. So, for a particular value of n, we know this n number of k value will be there. Now, for a particular k, for a particular angular momentum, again it is quantized in space, and this quantum number has come. Okay. Now, cos phi value, it can be maximum value is plus minus 1, limit value, and 0 also possible. So, when cos phi is 0, say m will be 0. When cos phi equal to plus minus 1, so these two can be equal, m can be plus minus k then. Okay. So, m value is allowed 0 value and plus minus up to plus minus k. Okay. Because m cannot be greater than k, it can only be less than equal to k. M can be only less than equal to k because of this cos phi. Okay. So, what we are getting? So, for a particular k value, for a particular n value, we will get n number of k value, and for a particular k value, we will get 2k plus 1 number of m value, m value will get, right. say k equal to 2. So, means -2, -1, 0, +1, +2. So, that will be the value of m. So, we will get 5 value. So, k equal to 2. So, it is we will get. So, this m basically m value will be at this how many number of k for a particular n value. So, n number of k value we will get for a particular n value, we will get n number of k value. Okay. Okay. So, I think I am not writing properly. So, I think just so for a particular n value. So, I will get how many k value, and I will get for a particular k value how many I will get m value. Okay. So, it's here I will get for a particular n value, whatever this, if it is n value is n. So, here I will get this n number of k value, and for particular k value, if it is k, then I will get 2k plus 1 number of m value. Okay. So, this is the space quantization, and considering the space quantization, the energy expression is not change. Energy expression is not change. E n k whatever we got, okay, minus E n etc. whatever I got. So, this it will not change. Okay. So, whatever the sodium D1, D2 lines, whatever the this hydrogen H alpha line, this fine structure of hydrogen H alpha lines. So, that nothing to do with that one after introducing the quantum quantization, but this quantum quantization was able to explain the Zeeman effect, normal Zeeman effect. It was not able to explain the anomalous Zeeman effect, that we will see later on, but it was able to explain the normal Zeeman effect. How? So, that is what I want to discuss. So, when electron, you see, when we are applying magnetic field, if magnetic field interact with the electron or with the atom, okay, so then there will be change of energy due to interaction. There will be change of energy, potential energy mainly. Okay. So, now that energy we have to find out, and we have to see whether it depends on this value, depends on m or not. If it depends on n, then in energy level another quantization quantum number will be introduced, and we may see the more splitting of the energy levels. So, how it interact? So, basically it is a magnetic interaction, magnetic field. Now, if atom have magnetic some magnetic property, some it shows the magnetic property. So, then this interaction is possible. Electric field will interact because electron have charge, okay, electronic charge. So, electric field will interact, but magnetic field, why it should interact? So, if electron have or this its electronic orbit, moving electron have the magnetic property, then only there is a possibility of interaction. So, it is true that this electrons in the orbit, it has magnetic moment. So, that we will find out. So, say for simple case, let us take a circular orbit. So, electrons are moving, its radius is say a, okay. Its mass is m, electron mass is m, and its velocity is v, okay. It is moving, it is moving. So it is moving, so it will have this angular momentum, it will have the angular momentum pk. So, that we have seen. Now, when electron is moving in an orbit with velocity v, then from electrodynamics we know this this orbit will act as a magnetic shell. This orbit will act as a magnetic shell, okay. If current circulate in a closed loop, then that loop act as a behave like a magnetic moment or magnetic shell, and this magnetic moment of this orbit, this shell will be mu equal to it's I into A, area of the loop, and I is the current passing through the loop. So, now I, what is I? When charge electron E is moving, so electron charge E, it is moving, okay. Now, current is per unit time, how many times it is passing through a point, okay. So, that is the current, okay. So, if I take frequency nu, means per unit time it is nu times it is circulating, that means that charge E, it is circulating nu times. So, total charge circulating in per unit time, that will be E nu. So, that will be the current basically, I equal to E nu I can write. So, nu equal to E one can write 2 pi by omega, angular frequency 2 pi by omega, okay. So, that is the I, and what will be the area? Area is the circular orbit, it is pi a square, okay. So, your mu will be here, this magnetic moment of this electron, it will be pi a square sorry, it is just I did mistake, it is not 2 pi by omega, omega by 2 pi, yes, omega by 2 pi, because omega angular velocity is equal to 2 pi into frequency. So, then you are getting, if I multiply these two, so pi will go. So, I will get E omega a square by 2, E omega a square by 2, okay, E omega a square by 2. So, that is the magnetic moment of the electron, okay. Motion is rotating in a orbit. So, it depends on the electronic charge, its angular momentum, and this radius, okay. So, you remember that this is E omega a square, omega, okay, and this from here that Bohr radius was yes, okay. So, that in terms of Bohr radius also we can define this. So, before that what we can do, so what we are getting here, this electron is rotating, okay, in a orbit. So, it has angular momentum pk, and since it has angular momentum, means it is in motion in orbit. So, corresponding magnetic moment we are getting, So, that magnetic moment corresponding, if it is for say k orbitals, if we consider, so then we can tell this the mu k. So, this electron is in kth orbital. So, this will get pk and corresponding magnetic moment we will get uk. So, now this pk is your pk equal to k is cross, pk equal to k is cross, and then we have relation that pk equal to h cross, and from here if we put pk, it is k h cross cos phi pk. One can write also k h cross cos phi equal to m h cross. From there we took the ratio m by k, that has to be equal to cos phi. So, here now I mu k equal to here, if I take the ratio of pk and mu k. So, these two I have, okay. So, if I take ratio of these two, so if you write mu k by pk, if I write mu k by pk, so what I will get? I will get here e omega square by 2, and here I will get k h cross, right. K h cross. Now, from this from here we would like to find out cos phi equal to m k square. Okay. Pk I can actually pk I can also write in terms of this angular momentum. Pk I can write. So, that is there, k h cross is there, but here since mu k I have written in terms of omega and a square. So, pk one can write angular momentum. What is angular momentum? mvr, right? mvr, mass into v into r. Okay. So, here r we have taken this a, and v one can write since we have considered this angular velocity is omega. So, v we can here since we have used omega. So, here I can use omega. So, v equal to omega r or omega a. So, basically m omega a square, pk equal to m omega a square. So, here instead of that one, let us, because I have to use same way with same parameter. So, now here pk equal to, I can write m omega a square, okay. So, this is giving me this equal to a square will go, and I will get e omega by omega also will go, so I will get e by 2m. It is very interesting to see that mu k by pk equal to constant e by 2m, m e a constant. So, this is a constant. So, this constant is called or this ratio is constant. So, is called e by 2m is called gyromagnetic, or people tell gyro, whatever, gyromagnetic ratio. Okay. So, so ultimately what I am getting? So, mu k equal to I am getting E by 2m into pk. Okay. Now, pk one can replace k h cross, pk one can replace by k h cross, k h cross. Okay. So, I am writing h cross here. Now, here this again you can see this is constant, and this constant if I write that k into this constant is mu v. So, mu v is called Bohr magneton, mu v is called Bohr magneton, Bohr magneton. It is called Bohr magneton, and it is very interesting to see that this magnetic moment is quantized, right, is quantized, and that it is quantized in terms of this, it is a smallest unit mu v, smallest unit is mu v. It just mu v is like the charge of the smallest unit of charge, you know, this electronic charge, whatever E. So, in E we taken as a universal constant of charge. Okay. So, and we express the other charge in terms of this E. So, 2E, 3, 4E, 5E, etc. Similarly, here this magnetic moment, that is we express in terms of this mu v, 2 mu v, 3 mu v, 4 mu v, because this k value, you know, this it can take 1, 2, 3, 4, 5 value. So, mu 1 for k equal to 1 for S cell, it will be mu v, for P cell, sub cell basically, it will be 2 mu v, then 3 mu v, 4 mu v. Okay. So, this is one basic unit of magnetic moment, it is called Bohr magneton. It is called Bohr magneton. Why it is called Bohr magneton? Now, this E h cross by 2m, this is this will come, this comes basically when it is a electron, this moment, this is the moment of electron in a hydrogen, this Bohr orbit, in a Bohr orbit, n equal to 1. So, Bohr orbit is always n equal to 1 and this radius is 0.51 angstrom. So, that is the fixed, and electron in that orbit, it will show the magnetic moment, because it shows when it in a moving in orbit, so it shows the magnetic moment. So, that magnetic moment, whatever the magnitude of that magnetic moment, that is mu v, and its value most probably mu v equal to mu v value 8, I have to see 8.78 into 10 to the power 10, okay, 8.78 2 into 10 to the power 10 joule, it is right, joule per Tesla. Yeah, I think unit is joule per Tesla. No, this 9.274 into 10 to the joule per Tesla. It is the wrong value. I think I have to. It is wrong value. It is 9.27. What is that value? 9.274. 9.274 into 10 to the power minus 24. 10 to the power minus 24 joule per Tesla. Yes. So, that is the, this is the universal constant for magnetic moment, This is the universal constant for magnetic moment. Okay. And now we got the relation mu k like pk, we got k equals, and mu k is basically what we got, k mu v, okay. So, this is in terms of h cross, it's the h cross is the unit of angular momentum, and mu v, that is the unit of magnetic moment. Okay. So, this is the relation. So, what happens? So, atom have electron, and electron are in motion in different orbits. So, it has magnetic moment. So, now if I apply magnetic field, so we will get there will be interaction between the magnetic moment and magnetic field, and due to this interaction there will be change of energy, and that energy, potential energy, that is from electrodynamics one can get this energy due to magnetic field, say B. So, that is minus mu k dot B. Okay. So, that will be the energy. Okay. So, so now there will be change of energy of the electrons, means energy levels of the atoms. Okay. So, that we will find out in next class. So, I will stop here. Thank you.